Thanks, Dennis. So I actually want to start with a question for you all today. How many of you are working on something complex, something hard, a challenging problem in your day-to-day work? Okay, quite a few hands. Okay, cool. And when you actually think about that, I want you actually to think about where does that complexity come from? Does the complexity come from the fact that the thing that you're doing is just a really hard problem that you're trying to solve? Does it come from the fact you're building a legacy system that's running on a 20-year-old Windows server running .NET Framework 1? Because that's got its own set of problems, right? Or is it that you chose to run your application on Kubernetes? Don't think I need to say anything else about the complexity there, do I? Software development is a complex thing, and at its core, this is a talk about managing complexity. And by the end of this talk, you're going to walk away with a deeper understanding of how you can build and run and ship software, focusing on only the necessary complexity, the complexity that all of your users care about. I'm James Eastham. I'm a developer advocate at Datadog. I'm a Microsoft MVP. I'm an AWS community builder. And if any of you have ever heard me talk before, you'll know that there's one thing I love talking about almost as much as serverless. That is, of course, pizza. And for the rest of this talk, I need you all to forget your day jobs, forget your Jira backlog, forget your product manager and the pressure they put on you, forget your on-call. Actually, if you're on-call, if your page goes off, go and sort that, please. Because you're all now developers for plant-based pizza. And the application you've got today is a big monolithic system running on a virtual machine in the cloud. And up until this point, this has served you well. It's allowed you to scale. It's allowed you to get to the point that you're at today. But you've started to hit a little bit of an inflection point. The size of the code base versus the number of developers operating on the code base has started to cause you quite a lot of problems. You regularly are encountering merge conflicts. People are getting frustrated. They're battling with each other, trying to ship features. Everybody's just kind of getting in each other's way. No one's more frustrated, though, than Helen. Helen's your CTO, and one day you receive a message in Slack off your CTO. You think that's kind of strange. Maybe she's finally noticing all the good work that I'm doing. Maybe it's finally time for that promotion. So you jump on a call with Helen, and your excitement quickly dissipates at that point. Because Helen set you a new task. You're going to be the first person responsible for breaking out the first service from the monolith. That's your job. She sets you some constraints, though. You're going to be a one-person team. You're the only person working on this project. You've got no support from the support teams, no support from the infrastructure teams. It is all on you to break out this service from the monolith. And just before the call ends, she adds another slightly little caveat that is your promotion to staff engineer relies on the success of this project. Not quite as exciting now, is it? A little bit stressed, actually. So you go off and you have a look at the code base for the monolith, and you decide that the menu service is the service that you want to break out into its own microservice. You pick this service because it's not a tier 0, absolutely critical, can't go offline service, but it's also not something that's so completely irrelevant that nobody had noticed if it broke. And that's generally a pretty good heuristic if you're starting to try and modernize and migrate things. And it's here that you encounter your first problem. The first problem you encounter is a problem of complexity. And there's two different types of complexity that it's really important to distinguish between. There's essential complexity. Essential complexity is the complexity that's inherent to the problem you're trying to solve. All the software all of you are building will have a problem that it's trying to solve. That's kind of the point in building the software, right? You're solving a problem. And different services will have different amounts of complexity. The menu service that you're going to break out, it needs to be highly performant, and it needs to be reasonably available, because that's the first thing people are going to see when they come along and try and order a pizza. A payment service would have a completely different amount of essential complexity. Accidental complexity, though, this is the much more dangerous one. This is the complexity that comes from the decisions that you choose to make about how you build and run your software. And when you think about building software in 2025, it can feel a little bit like this. It can feel like there's an awful lot of accidental complexity that you need to deal with. Microservices, event-driven architecture, serverless, cloud providers, service discovery, vendor lock-in, and this tiny little thing called AI. I don't know if you've heard about that yet. It can feel a little bit like this, trying to build modern software. You're dealing with all of this complexity. How would you actually pick the right complexity, pick the right thing to focus on? And this is where, in my opinion, serverless gets so powerful. And I want to just quickly level set on what the word serverless actually means, in my opinion, because I think it's been co-opted by marketing teams, the services that, are they serverless? Are they serverless? Is it scale to zero? Does it mean pay per use? What does the word actually mean? And Dave talked a little bit about this in the keynotes. You should view serverless as a spectrum, not as a binary decision. You don't choose to be serverless or not serverless. You choose to be more or less serverless. And Dave had a similar graph to this, a similar spectrum to this, in the keynote. But I think there was an important thing missing off that graphic that Dave showed. At one end of this spectrum, you've got the lowest amount of operational overhead, being as serverless as physically possible. What you lose there, though, is flexibility. Most of these serverless services are really opinionated about how you should write your code, how you should build your software, how you should do things. So although you lower your operational overhead, you also lose flexibility in your infrastructure. What does this actually look like from a service perspective? Well, obviously, at the far end of this spectrum, you've got Lambda. The kind of OG, the service that coined the word serverless, if you will. Scales to zero, scales up when there's work to do, scales back down when there's no work to do, it's pay per use. You write your code, you push your code, AWS handles the rest. But this might not always be the right choice for the workload. As you take a walk down this spectrum, you start to come across services like ECS, a container orchestrator. I can give ECS a container and it will orchestrate that. There's very little overhead there. And if you couple that with Fargate as the underlying compute, you're running containers here with basically the same amount of operational overhead as with Lambda, albeit they don't automatically scale to zero, but from an operational perspective, it's very, very similar. Of course, if you keep walking down the spectrum, you start to get to your Kubernetes services, EKS, which AWS take on the responsibility for the control plane. Great. You've still got to think about everything else inside that cluster, upgrading the cluster, managing the things you install on the cluster, working out how to deploy things to the cluster. And then, of course, right off the far end, you've got virtual machines. Now, in most cases, you want to sit as far right on this spectrum as possible, but there might be use cases where you may not want to be as far right as possible. One of the best heuristics I've ever heard for this, back when I was at AWS, they said internally, if your ability to dynamically scale infrastructure is a core differentiator for your business, Kubernetes is a good solution. If you need to dynamically scale up and down GPU-enabled EC2 instances and all the applications running on those GPU-enabled instances, then yeah, Kubernetes might be suitable. But for most use cases, thinking serverless first is the way to go. Sitting as far right on this spectrum as possible, aiming to reduce your operational overhead as much as possible. So that's what you decide to do with the first version of this menu service that you're breaking out. You sit as far right as possible, and you build what is the kind of typical serverless API. You've got API gateway, you've got a Lambda function per route on your API, talking to a DynamoDB table behind the scenes. So you write the code for the new version of your menu service, you push that out, you ship it to AWS, and you think, well, fantastic, great, we're done, right? The promise of serverless is that you can build and you can ship applications and celebrate about your wins, celebrate about the promotion you're about to get. If only things were that simple. Because Helen comes back to you again, and honestly, she's not as happy as she looks in this photograph, believe me. She's actually pretty mad. You just have to use your imagination here a little bit. Because one of the core complexities, if you will, of this menu service is that it needs to be really, really consistently performant. This is the same page that's going to load every time someone hits the website. So it needs to be performant all the time. And users are getting frustrated because intermittently things aren't really working, intermittently things are slowing down a little bit. Thankfully, because you're all fantastic developers, you added some telemetry to your application. So you go off and you have a look at your observability backend, and you have a look at exactly what is happening when someone's loading the menu, loading the actual available menu items. And you can see that the total response time of the API is about a second, and 50% of that second is made up of this block here. The dreaded Lambda cold start. And I think cold starts get a little bit of a bad rap, if I'm honest. They get a bad rap because when you first start working with Lambda, when you first start developing with Lambda, every time you push a new version of your code, you are guaranteed to get a cold start. So as a developer, you're going to see a lot of cold starts. You're going to write some code, you're going to push that code, maybe it doesn't quite work, you see a cold start, push it again, see a cold start. It can give you this feeling that, these cold start things are a massive problem. So what I would always say if you're starting to work with Lambda is run something like real-world load through your system. One of the curious things about Lambda is that the more load you put through it, the better it starts to perform, the less cold starts you will start to see. The other thing I just want to say on cold starts as I put it up there is that when you think about the cold start of a Lambda function relative to, say, I don't know, your application running on an EC2 instance needs to scale up, I would be pretty confident that the cold start of the Lambda function will be less than the cold start of the EC2 instance. But over all the years I've been building serverless applications, working with people at AWS, I've seen a lot of people do a lot of crazy things trying to force fit their application into Lambda. Playing around with provision concurrency, really trying to get that right, applying a whole load of optimizations to their code base, introducing new libraries, writing hacky little scripts that hit the function every 30 seconds. Put hands up if you've done that before, by the way. Less people than I thought. Good job, everyone. So you're at this inflection point now. You can either choose to potentially increase your accidental complexity, apply all of these optimizations, all of these things to try and force fit your application into that lack of flexibility that Lambda gives you. Or you can choose to revisit the spectrum. You can start to think about, well, is this actually the right way to build things? Do we instead maybe take a look at taking a step further down this spectrum? So we're not necessarily taking on more operational overhead if we adopt ECS and Fargate, but we now need to containerize our application to run it there. And this is where you start to hit your second problem. Problem of change. In almost every single system I've ever worked on, this has been the #1 constant through all of them. Whether it's changing business requirements, changing user profiles, changing user volumes, changing business focuses, heck, even changes in government somewhere else in the world that massively affects the economic situation of us all. Change is absolutely inevitable. But now you're in a little bit of trouble. You're in a little bit of trouble because you've written your code to run inside a serverless function, right? And if you believe anything you read online, that because you've chosen to run your code in Lambda, you're now locked into AWS Lambda forevermore, and you can never leave AWS Lambda. And if you think about it, if you want to move some code from Lambda to a container, well, you need to actually adopt some kind of web framework, whether that be ASP.NET, Spring Boot, Quarkus, Express, whatever it is in whatever programming language you're using. So you've got a problem here, because you've got this code that's built for Lambda, and you want that to run inside a container. So you go off and you have a look at your code of your Lambda function. This really big, long, single code file. And if we actually work through this a little bit, I know this is .NET code, don't worry, I will talk you through it. .NET's not for everybody, I appreciate that, apart from Matt sat over there. Inside your handler here, you're importing the AWS SDK, right? You've all done that before in a handler, you've imported the AWS SDK. And then you're dealing with the actual inbound event payload. You're taking this API gateway event payload, you're doing some transformations on that to do something with that inbound payload. You're then making an SDK call to DynamoDB. You're running a whole bunch of business logic inside this Lambda function. This is the actual core business logic. This is the essential complexity you're trying to solve. Making another call to DynamoDB before then returning a response back in the format that API Gateway expects. And I'm sure you've all written Lambda functions like this, right? You've got one handler. Lambda function should be single purpose. Everything goes in that handler. Happy days. If you write Lambda functions like this, you should be thinking to yourself, you've made a huge mistake. Because what you've done here is everything now related to your application, the compute, the business logic, the storage, the messaging, the dependencies, the SDKs, the API calls, everything is in this single code file. There's no modularity, there's no separation of concerns. What you've built yourself here is a complete lack of flexibility. And with the speed things are moving at in software today, I actually think this is one of the most important things you can build into any system that you build. Flexibility, evolvability, whatever you want to call it. This ability to deal with change is absolutely, it's vital. And this was actually codified back in the 60s by a psychologist called Ross Ashby. And Ashby's law of requisite variety states when the variety or complexity of the environment exceeds the capacity of a system, the environment will dominate and ultimately destroy the system. What Ashby's saying here is that if your system can't deal with the complexities of the environment around it, the environment will always beat the system, always. And when I discovered this quote, I was reading this book. Has anyone come across or read this book, The Architect's Paradox, Barry O'Reilly? Okay, cool. So if you're not familiar with Barry O'Reilly, he's doing an awful lot of fantastic work at the minute about software architecture. Go and follow him on LinkedIn, go and watch his talks, go and buy his books. They're absolutely brilliant. And one of the key takeaways in this book is that software engineering operates in a really interesting place. Because the code we write, the things we do, is incredibly deterministic. It's one of the things of why we write software, right? You tell a computer to do a thing and it does that same thing over and over again forever. But when you compare this to more traditional engineering, if I'm engineering a building, for example, that building is kind of the same as the software. If I build a building in a certain way, it's going to be that way forever. But the environment the building operates in is also pretty static, right? I don't know about you, but I've never seen the laws of physics change in my lifetime, at least. Whereas software engineering is this really deterministic thing operating in this incredibly non-deterministic environment, this really complex, really chaotic, constantly changing environment. So how do you build software that deals with that complexity around it that, frankly, you need to deal with because the environment otherwise will always win? Now, I realize that's a little bit philosophical, a little bit kind of theoretical. What does this actually mean in practice for all of you? Well, when it comes to actually writing the code of your application, there's a few really simple things that you can do when you're actually coding your system. The first is to adopt some kind of structured pattern in how you structure your code base. Whether that be ports and adapters, hexagonal architecture, clean architecture, all these styles of structuring a code base are doing the same fundamental thing. They're separating your application concerns, your essential complexity, from the accidental complexity around it that you need to adopt to be able to run this system in the first place. And all these styles of structuring a code base work in kind of the same way. At the core, you've got your core business logic. This is the code that solves the business problem, that solves that essential complexity. It has no external dependencies. It doesn't know about AWS. It doesn't know about Lambda. It doesn't know about any SDKs. Pure business logic. And all this business logic exposes is primary and secondary ports. A primary port allows something to call into your business logic. A secondary port allows your business logic to call out to something. You've then got this idea of adapters. And again, all these styles call these things slightly different. A driving adapter is something that comes from the external world and calls into your business logic. This is your users making a request into your system, a message on an SQS queue. And then at the other side, you've got driven adapters. These are the implementations that talk out to your database, that talk out to an AWS SDK, that talk out to a message queue, for example. And if we zoom this out a little bit and we actually layer the AWS services on top of this, all that your Lambda function should do is adapt the inbound payload into something that your business logic understands. That is all your Lambda handler should do, should be responsible for. Which means you then write Lambda functions that look a little bit like this. One being, they're a little bit simpler to understand. There's just less lines of code. It's easier to kind of rationalize exactly what this function is doing. And all it's doing now in this handler is, again, adapting the inbound payload from API Gateway, taking that payload in, adapting that into something that my business logic understands, and then all it is doing is calling this handle method, this handle function, passing in that adapted inbound request. That handle method is now pure business logic. Again, easier to understand, easier to rationalize. If I want to change how my code solves the essential complexity of my system, all I am changing is pure business logic, the pure logic for solving the problem. And then all my Lambda function is doing after that is adapting the response back to a format that Lambda needs it to be adapted to. Now you might think, what has all that got to do with serverless or containers? Well, this is where we are today. If we write our code in this way, we've got that Lambda adapter, we've got our business logic, and we've got our call out to DynamoDB right down at the bottom. Now when it comes to say, hey, actually, you know what? Lambda wasn't the right fit for this workload. Let's run it in a container instead. All I need to change is that top left box. All I need to do is switch out my Lambda function, that Lambda handler, for some kind of web framework. This is a .NET application. It happens to be SP.NET. It could be Express. It could be Flask. It could be Spring Boot, whatever the web framework is in the programming language that you're working with. This also helps to tackle the horrible vendor lock-in conversation. Obviously, if you use serverless, you are tied into that cloud provider forever, aren't you? I'm expecting some shaking heads there. Oh well. If you structure your code base in this way, you're keeping yourself flexible. You're not locking your USP, your core business logic, into something that a specific cloud provider puts upon you. Your code is now flexible. And actually, if you build your applications in this way, if you structure your code in this way, it is almost never your compute that is going to lock you in. It's almost always going to be your data that locks you into a cloud provider. Really quick sidebar for a second, but when I was at AWS, I was consulting with a big energy company, and we were helping them migrate from Azure to AWS. And they were really excited because they'd used Kubernetes everywhere. They're like, this migration will be easy. It's so easy. We've got Kubernetes. Kubernetes runs everywhere. It's fantastic. So we went and had a look at the first application they wanted to migrate, Kubernetes on Azure, fine. They were using Cosmos DB as the database provider. Now, I don't know if you know Azure very well. Cosmos DB is kind of Azure's proprietary database technology, and you can't run Cosmos DB on AWS. So although Kubernetes would have moved, the data, of course, wouldn't. So structuring your application in this way, structuring your code in this way, allows you to make these really strategic choices. Actually, instead of using Lambda, maybe Lambda's not quite the right fit for our workload. We can pick that up and we can drop that into a container. And the work to do that is not intensely difficult. So you think, wow, we're making progress now. It's a win now. Helen's back again. She's still not pleased. Still not happy. Because although you've now got this performant web API, you've strategically made the right decision for the compute you want to use, it's now performant, your users are happy, there's a key piece of functionality missing from your system. There's this functionality in the website to do most ordered pizzas. And for that to work, your container that's running on ECS needs to react to some events that another service is publishing. The order service is publishing an orders completed event. You need to consume that and use that to increment the number of times a pizza has been ordered, and you can use that to then expose that these are the most ordered pizzas. And you might think, and I've seen this happen in companies, well, because now we're using ECS and we're doing containers, then we must do containers everywhere. Therefore, we're going to write some code to run in a container to deal with these messages that are coming from the orders service. And most programming languages have the ability to start up some kind of background task, to run some kind of loop, and iterate over messages on a loop. And whatever programming language you're using, it'd look something similar to this. You'd have the AWS SDK, you'd make a call to receive message on the AWS SDK, on the SQS API, you'd iterate over all of the messages, you'd run some business logic, and then you'd delete the message from the queue. And again, here, we're practicing that same thing of separating the infrastructure concerns from the application concerns. When we get the message, all we're doing is calling into this order completed handler. That is our core business logic for handling orders being completed. And then, of course, you need to delete the message. And this works perfectly. You're doing containers now, so everything is running in a container, and you're happy, right? But when you think about this, now you've got this container that's running 24 hours a day, 7 days a week, 365 days a year, even though there's no messages potentially on the queue to be processed. So again, because you're pragmatic developers now, you go back and you revisit this spectrum and you think, well, maybe this is the right time to walk a bit further back up the spectrum. Back to these services where reactivity is their superpower. The core purpose of any functions as a service is to react to events. AWS will tell you that. And although the API gateway input might be an event, it's not really an event. It's not really an event in the kind of event-driven architecture sense. Whereas functions are built to react to events, to react to things that are happening. And when you have a look at the Lambda handler for something that's reacting to an SQS event, it's pretty much the same as what we had running in the container. Again, because we've practiced this good code design, this good structure of our code, we're iterating over the records that come from the SQS event and calling into our business logic. And if we compare these two things side by side, the one on the left being the container, the one on the right being the Lambda function, there's basically these two lines of code that are exactly the same between the two of them. All the rest of the code on the left-hand one is just the plumbing to actually make the call to SQS and get the messages from SQS, which of course in Lambda, AWS are doing that on your behalf. They're making them calls to the SQS API on your behalf. And what I think this leads to is a really pragmatic pattern for building modern applications. For when you've got a web API, you've got some kind of API that needs to be available for people to access, it needs to be performant, it needs to be available. No matter when a user comes along, you want it to be fast. Containers are good for that. A long-running container will help you do that. But when you've got these more reactive, event-driven things, you're reacting to a message on a queue, a message on a stream, use the right tool for the job. Use functions for the thing they are meant to be used for reacting to events. And now, she's actually happy now, by the way, you'll be pleased to know. Because the user experience in the front end is good. Users have got the snappy response time that they expect, and it's consistent, it's double-digit milliseconds, they're happy. And this functionality where you need to react to events that's happening in a really efficient way. And you've done this, whether you're using ECS and Fargate, whether you're using Lambda, you've done that in a way that massively reduces your operational overhead. There's very little operational overhead in either option there. So to come back to this question, serverless or containers, and as I hope you've realized, this is kind of the wrong way to frame this whole thing, because serverless, as Dave said in the keynote, is an operational model. Serverless is a way of thinking about how you're going to run your application, doing that in a way that reduces the operational overhead as much as possible. And containers are just a way of packaging your application. Whether you package your application as a container, you could package it as a container and run it on Lambda if you wanted to. So I think a different way to think about this, to think about when you're thinking about the different things in your system, to think about if the thing you're building is short-lived or long-lived. Would it benefit from spinning up, doing some work, and spinning down again? It's short-lived. I'm processing a message on a queue, an event on an event bus, a message on a stream. That case, Lambda can be a really good option for that. If you've got something that would benefit from being a long-lived workload, where it's always there, always waiting for responses, no matter when a user comes along, long-running containers can be a better fit for that. Now, of course, this is really good for plant-based pizza, but none of you actually work for plant-based pizza. So what does this actually mean for all of you when you go back to your day jobs tomorrow, you go back to your day job next week, whenever it is that you're next at work? The first and most important one is to focus on the right type of complexity. Focus on the complexity that your users care about. Your users do not care how well you can upgrade a Kubernetes cluster. Your users care about your software solving the problem it was built to solve. And if it doesn't solve that problem, then genuinely what is the point in building it? Secondly, design with flexibility in mind. With the fast changing environment we've got at the minute, we need to keep flexibility, evolvability as a first-class citizen. Whether that's in your code base with how you actually structure your code base, and this doesn't need to be a heavyweight process with 100 different libraries, it can be simply one layer of abstraction. Or even at an architectural level, adopting things like event-driven architecture, using messaging, allow you to build evolvability into your architecture. Now that, of course, brings about its own set of challenges, but it can at least keep that flexibility there as an option. And finally, choose the right tool for the job. I've seen so many teams and so many people over the years be dogmatic about, we are a serverless shop, therefore we must run everything on Lambda. Lambda isn't the right fit for every workload. I used to have that same opinion myself. So be pragmatic, choose the right tool for the job. I just want to finish with a really quick story. Does anybody remember this article from a few years ago now from the Amazon Prime video team? Does anyone remember this? If you remember, this caused absolute carnage in the serverless community, and internally at AWS it caused a little bit of carnage as well, because the kind of way this article was framed was that serverless is really expensive, microservices are really expensive, instead you should just go back to build a monolith. Now, aside from the fact this specific application they're talking about was part of a larger microservices architecture, so forgetting the fact that microservices to monolith isn't really a thing here, what I think this article did point out is some really pragmatic engineering decisions. If you scroll down through this article, there's a line a little bit further down that says, this allowed us to reuse a lot of code and quickly migrate to a new architecture. Now, of course, I'm not on the Prime Video team. I wasn't on the Prime Video team, so I don't know the internals of exactly how this code was written. But my guess would be that they had really good separation of concerns, really good modularity, really good separation between their components in the code base. What this allowed them to do was to get started really quickly, get started with Lambda, run with serverless. And then when they got to a point where they realized that their initial assumptions weren't quite what they thought they were, they decided that, well, we need to pivot and we need to try a different option. They didn't dogmatically stick to everything must be serverless. They instead simply took that application and moved it and ran it on a container. It sounds to me like they did an excellent job of dealing with their accidental complexity. Thank you all very much for listening. I'm always absolutely honored when people come out to see me speak, so genuinely thank you all for coming to listen to me. I will take questions. I've got content on YouTube, content online. Feel free to go and check that out if you want. But thank you all for listening.
We've got time for some questions, don't we? Questions? Thanks, James. Brilliant. Any questions from the audience?
The slides are on
over
that
there,
QR
yeah.
code. Sorry, the slides are on that QR code as well, actually, if you want a copy of the slides.
There you go.
Thanks very much. Lovely talk. I think you're quite right in terms of separating that scaffolding layer from core business logic. Is something we think about and we try to do. I'm wondering if there's a cost we have to consider, the mental complexity that we have to pay every time we touch the code base versus the benefits we will get if at some point in the future we see the need to move left or right on the serverless scale. Is that something we should be thinking about? I mean, if I have something that's never going to change, why can't I just stick it all in one function and go home?
I mean, it's an excellent question. And I think I've tried to do this before, and the code ended up split across like 10 different libraries. So you can absolutely take this to an extreme where it causes more problems than it solves. One thing, I'm going to answer this two separate ways, if that's all right. The first one is for things that are your core. If you're familiar with domain-driven design, what you would call your core domain, your USP, the thing that differentiates your business from every other business on the planet, putting the time into patterns like these is really important. That additional bit of complexity is worthwhile, I think, for the potential that is the thing that makes your business. And if you ever need to change that or move that, you want that to be as easy as possible. For things that are in your supporting subdomain, things that aren't your core domain, I would probably agree with you that there's probably less need to be as prescriptive about this must always be the case. But for things that are your core USP, your core business logic, I would say that this is really important. The second thing I will say is that whilst you could argue that the layer of abstraction could make things harder to understand from like a mental load, you could also argue that it makes it easier, because when I'm looking at my Lambda function code, I know that that is only code that is dealing with Lambda. And when I'm looking at my business logic, I know that that's only my business logic, and I don't have my business logic mixed up with my Lambda function code. So yeah, I think if for stuff in your core domain, I think it's really important. For stuff that isn't in your core domain, I could see the argument for making that less so, but I still think it's really a valuable thing to do. Good question, though.
Anyone else? We have 8 minutes left, so don't be shy.
You can also come and ask me afterwards. Like I'm the kind of guy who wouldn't put my hand up and ask a question when with a microphone. So if you do have a question and you don't want to ask it now, then please come and ask me when I'm not stood on stage with a microphone. So the question was. So say that last bit again, sir. So the question was specifically about cold starts. What can you do to deal with them if they are causing a problem? So I think a lot of programming languages have, there's Lambda-specific features like turning on provision concurrency, which if you're not familiar will just keep a certain number of your Lambda functions warm all the time, so you don't have to deal with that cold start. So that's one thing that Lambda has built into it. There's a whole bunch of, depending on what programming language you're using, there's a whole bunch of optimizations you can do at like an application code level, particularly using like a compiled language like .NET or Java. Matt's talk later on is a really good example of things you can do there. Minimizing the amount of dependencies you have, minimizing what you're loading up at initialization time, because if you're loading in a gigabyte file from S3 when your Lambda function starts up, like that's obviously going to impact your cold start time. And then the final thing I would say is that, like I said in the talk, if you think cold starts are going to be a problem, run some actual load through your system, because typically the more load you put through consistent load, the less cold starts you'll start to see. When I was at AWS, we did a whole bunch of internal analytics, and I think the percentages were like 1% or 0.1% of all invocations across all of Lambda are cold starts. So if you've got like a consistent load through like an API, you would typically find that there's you see less than you might think than what you would see in your development environment. There's a whole thing I could get into about whether you should have single-purpose functions, whether you should run an entire API inside a single Lambda function. That's probably not a debate to get into for now, but if you want to know more about that, then just come and grab me afterwards.
Any more questions? Oh, here we go.
When you were comparing the different options, how did you work out cost up ahead when, I understand splitting the business logic up and the benefits of that, but the actual cost of running a Lambda, versus a container. Is there an easy way to work that out before just doing it?
So I had, there's another, this originally was an hour-long talk, and I've had to cut a lot of stuff out, and there was originally a whole bunch of stuff in there about cost and the cost dimension. It's really hard, just because of the billing model, to compare a Lambda function to a comparable EC2 instance, as an example. Obviously, Lambda, AWS have got like cost calculators, so if you've got a rough idea of what your throughput is going to be, you can obviously work out your cost for Lambda. Depending on how well you understand the programming language that you're using and the web frameworks, you could kind of look at how many concurrent requests do I think I could handle inside web framework of choice. Therefore, I'll need 10 running container instances. Therefore, I can do the maths to like kind of work that out. I think the really important thing you need to think about when you're thinking about cost is like the human cost, because as you start to move further down towards Kubernetes, towards EC2, there's a dimension that it's kind of hard to include, which is the human cost of, if you choose to use Kubernetes over Lambda, there's a human cost to doing that as well. But yeah, the maths gets kind of difficult to do like an apples to apples comparison. If you know your load, like what user load you're expecting, it gets a little bit easier.
Thank you.
So you said that you were dogmatic about Lambda in the past. So how do you deal with companies that say, are like that and have really good build tools for something like, it's like you have a platform team and they handle like your CI/CD pipelines, and they've got really good stuff for Lambda, or for building Lambda functions, but they don't really have great things for like EC2 or anything like that. On the left side of the scale, they don't really have the great things for that. Mm-hmm. How do you push your platform teams or advocate for those technologies to be better supported?
I mean, I think the first thing I would say is that if the company's all in on Lambda and they're getting a lot of success being all in on Lambda, then obviously there's no need to change just because you've heard me say something on stage, right? Like, just to acknowledge that first and foremost. I think the only way to have them kind of conversations is to try and frame it around like the business problem. So I use cold starts in this talk as an easy example, just because it's an easy thing to kind of to say as a downside to Lambda. It's not as big a problem as I think it is. But if you can find the good business reason as to why containers are a better fit than Lambda, that's a way you can start to get buy-in, because it's not just a case of I think we should use containers because we should be more dogmatic. It's a case of let's get buy-in from everybody because containers will give us this desirable business outcome that is desirable to our users. Yeah. Then it gets easier to get buy-in, and then the whole tooling conversation becomes interesting. I mean, I think there's an interesting argument because AWS have changed the billing model of Lambda, whereas you pay for inits all the time now. I think using containers as the deployment model to Lambda becomes a much more convincing option. So AJ Stivenberg, one of my colleagues at Datadog, a serverless hero, he's got a whole lot of analysis on his blog. And actually there's very little impact from a cold start time if you use a container or a zip file to package your application to Lambda. The historical thing used to be with zips you got init for free. Containers you paid for init. AWS have got rid of that now. So I actually think, I've not done an awful lot of work on this myself, but I think it becomes a really convincing thing because container tooling is so good, right, to build and package container images. I realise that doesn't answer your question directly, but I thought.
It's just that, I think sometimes I think I'm building stuff that might be better placed inside a containerized service instead. But because the tooling we have is so good and like the libraries we have are so good for serverless stuff, that you just end up going with what you know and what you use a lot.
Yeah, totally.
So, I was just wondering if you had any advice.
I think it would be. It's easy to say just build a POC and look at the data. But I realise you've got your day job, you've got things you actually have to do. But looking at what the convincing business reason is to do it, if you've got time to run a little pilot and say, you can then actually tangibly say, look, here is the benefits we would get from running this in a container, not in Lambda. Then you can start to get the buy-in to then start to put some time into adopting them tooling. Like just trying to push the tooling in, like force it in, is going to be a difficult thing to do.
I think we've probably got time for one more question before we take a break. Here we go. All right, I'll come around.
So you mentioned about Lambda optimization. at some point all of us try to bring out the best concurrency or optimize the code so it fits Lambda. At what point do we decide to go ahead with optimization or move to containerization?
I'd say a similar thing to the way I answered the last question. You know, the things we do, we're building things to solve a business problem. If you think you could put in, you know, if you think you could get the optimization with Lambda to a desirable level for the business, great. But if you don't think you will get there, then moving back to containers later. If you are trying to optimize to run in Lambda and you're practicing patterns like I've talked about where you separate the thing that is Lambda specific to the thing that the Lambda function is actually trying to do, it makes that pivot at a later date less painful. If you go and read that Amazon Prime Video article, for example, that's kind of what they did. They had it running in Lambda, they had it running in serverless technologies, they were trying to optimize it, they couldn't get to the optimization they wanted to, they realized it were going to be really expensive because they'd done certain things to keep their code modular and keep things separated. The move over to them run it on containers wasn't necessarily too difficult of a thing. So keeping that flexibility in mind would make it easier. There's not really a hard and fast rule to say, you know, if you've sunk 8 hours into trying optimizing it, then you should move. Like it doesn't really work like that. Your alternate option is just write everything in Rust. I mean, that works as well, I suppose.
Thank you. I think that's all the time we've got. Thank you very much, James, and for the good questions as well.